Here we have a SAT math problem. Okay, let's go to the question. In the figure above, a circle is inscribed in triangle PQR. If PQ equals to 3 and PR is equal to 4, what is the radius of the circle? Actually, the given triangle is a right triangle because we have right angle at P, and also it is a 3, 4, 5 right triangle because the lengths of two legs of the right triangle are 3 and 4. Then the length of the hypotenuse over here must be 5. Okay, our aim is to find the radius of the circle. Let me draw two radiuses. One is an horizontal radius. Let me draw it over here. And also let me draw another radius which is vertical. Okay, now I have drawn two radiuses. So one is horizontal radius and another one is vertical radius. And here we have the center of the circle. And I assume R as the radius of the circle. Okay, now, so this vertical line segment over here and this vertical line segment over here are parallel. So since the length of this line segment is R, which is the radius of the circle, so the length of this vertical line segment also must be R. The same thing. So here we have an horizontal line segment, here we have an horizontal line segment. They are parallel, so they must be having equal length. Already we know that the length of this line segment is R, which is the radius of the circle. Then the length of this line segment is also R. And also we can consider a concept, that is whenever I draw two tangents from the same external point to a circle, the two tangents must be equal in length. Actually here the length of the tangent is measured, the distance between the external point and the point of tangency on the circle. So here this is a tangent drawn to the circle from the external point P over here, and this is a tangent drawn to the circle from the same external point P, so that they are equal in length. And this is the length of the tangent line which has been drawn to the circle from the external point Q. And let's consider the point of tangents over here. So the length of this line segment represents the length of the tangent drawn from the external point Q to the circle. And also here we can consider this line segment. So this represents the length of the tangent line which has been drawn from the external point R to the circle. Okay, now let's find the length of this tangent line which has been drawn from the external point Q to the circle. Already we know that this is the length of this tangent line is R, and the total length is 3. Then what is the length of this tangent line? So that is 3 negative R. And what is the length of this tangent line? That one also must be 3 negative R. Because both the tangents are drawn from the same external point Q, so they must be equal in length. And the total length of the side PR of the triangle is 4, and we know that the length of this line segment is R. Then what is the length of the tangent line we have over here, which has been drawn from the external point R? That is 4 negative R, and we have the same length over here, 4 negative R for the length of this tangent line, because this tangent line and this tangent line are drawn from the same external point R to the circle. They must be equal in length. Okay, already we know the length of the hypotenuse of the triangle QR, that is 5. Okay, now when I add the length of this line segment and this line segment, that is equal to the total length of the hypotenuse of 5. That is 3 negative R, the length of this line segment, positive the length of this line segment, that is 4 negative R. When I add that is equal to the total length of the hypotenuse, that is 5. Okay, now we can combine this negative R and negative R. I'm getting negative 2R. When I combine this 3 and 4, I'm getting positive 7 equals to 5. Okay, now to solve for R, I have to isolate R. First, let me get rid of this positive 7. For that, I have to subtract 7 from both sides. Then I'm getting negative 2R equals to 5. Negative 7 will become negative 2. Now to solve for R, I divide both sides by negative 2. When I do so, this negative to negative will cancel. Then R equals to this negative negative will cancel. 2 divided by 2 is just 1. I got the radius of the circle. The radius of the circle is 1.